Okay, so I'm not sure if everyone's planning on sticking around for all the individual topics. We do have 5 of them. I haven't actually run through these yet, so I don't know how long each one's going to take. We're going to try to keep it to 10 minutes apiece. But who knows? If anyone pops in the middle, they might not quite get what they were hoping for. But everyone who sticks around will hopefully get to see all of them.
Introduce me kids in the future. And in the future, if he does keep bringing me kids.
We got someone.
Then you pay.
So I'm Josh Johnson. I'm a data architect with the University Technology Office. I focus on kind of structuring data and integrations and how we can improve those things, supporting use cases that might not be traditionally kind of interest to the university. And we'll see a little bit about that with the data architecture. This is the last session of this bunch. So we're going to start out with Zoom data. Zoom data is something I've been working on for a few months now, since getting to UTO. It was obviously very interesting to a lot of people as we went remote, specifically students, and how they were taking advantage of the sync class modalities. So, we offered students the ability to either show up in person or online, whereas before they all had to be in person, and try to figure out who was actually showing up online, and was that working? So we're doing a little bit more with it than just student work. We're doing some stuff with business meetings, for instance. So looking at who actually participated in a meeting, something like the RWUG meetings specifically. We're looking at how is this population growing over time? Are people generally showing up to all of them, or what percentage of them? Trying to get better insight into that population. So there's a lot of stuff going on. I'm going to show you right now kind of what the current objectives are. A lot of this is still being developed. So I'm going to reference some tables that don't exist yet. If anyone is interested in this, just send me a Slack. I've got Alteryx workflows all over the place. I'm sending copies of data to various analytics user database schemas for people who want to play around with the data. Just right now, it's not quite in the warehouse. Getting close. So this is what the daily process looks like. The data engineering people actually connect to Zoom's API. So they don't have necessarily a database we're replicating like we might have 5 years ago with something like this. They're actually making calls using Python and pulling back pages of records and then compiling all those into S3 files. The data structures team picks up those S3 files, parses out the JSON that's returned by the API, and creates relational tables in the Redshift data warehouse. And then what we're going to be focusing on a lot in the next couple months probably is how do we then take that raw data and make it more useful for downstream purposes. So again, Zoom doesn't know who a student is. Zoom doesn't know who an instructor is. So we have to merge it with PeopleSoft data to figure that stuff out, figure out who's who. So the raw tables that are coming in with the actual API data, we have a user level table, we have a meeting level table, we have a meeting participants table, and then there's a couple that we may or may not end up building. One is another meeting level table. It just includes different information from a different API endpoint. And then there's actually, and some of you who work in the colleges specifically might be familiar with what's been done in MyISU that allows people to kind of customize what shows up in MyISU as far as Zoom links for specific classes or for specific instructors. So we're looking to probably also bring that into the warehouse so we can integrate that information as well. And those two TBD items are specifically intended to help us better tie the Zoom data to the PeopleSoft data, because there isn't a reliable unique identifier between those two systems. So the more data we have, the more reliable we can make those connections. beyond the raw tables, the enriched tables, the good stuff. And all this is going to be in the ASU learning schema. So it's the same place that you'd find Canvas data, Alex data, I believe edX data is in there. And that's all governed by Sheila Ainley in the provost office. But we're going to have, again, a user level table. But now we're going to take that raw data and we're going to say, well, this is the YMPL ID and the ASU right for this person. We have the meeting level table, but that meeting host, now you'll know what their ASU IDs are. And if that meeting appears to have actually been for a scheduled class section, we'll tell you what that class was. Meeting participant level, again, but now we're appending those participant IDs, so you'll know which students they are or which university employees they are if it's a business meeting. And then we kind of tweak things a little bit, and instead of focusing on here's the Zoom data and pulling in PeopleSoft data, we're going to take PeopleSoft data and pull in Zoom data. So with the Zoom PS class schedule, for instance, we know when classes are supposed to occur. So we'll have a table that just shows you all the classes and when they're supposed to occur. And then we're going to bring in the Zoom data. So you'll see, oh, this Zoom meeting ID was, you know, the actual occurrence of this class. Or this student's schedule, right? On Monday, they're supposed to take Math 117, then they take English 101. So you'll see the student schedule and then indicators for whether or not they actually attended a class remotely using Zoom at those points in time. So there's additional stuff we want to do beyond this, further aggregating things. So like creating a student level table. What percent of a student's sync classes are they attending remotely? When is the last time they attended a class? How long, you know, how many classes have they missed in the last week? Things like that that we can use to inform either advisor outreach, coach outreach, or potentially even predictive models to predict things like student persistence. So we're trying to transform this data, bring it together on the warehouse side so that you don't have to do it yourselves, because this stuff is definitely not intuitive, the way the connections happen. And then I have a little note down here, summarize statistics. So just like I mentioned, creating a student level table. Well, even within that meeting participant table, for instance, we can do something like what percent of those meeting participants were matched to students in that specific class, right? So we can create these aggregated metrics to help you analyze the meetings, the students, the instructors even. And some of this data does include things like, did a student share their screen during the meeting? Or was the meeting recorded? So there's some things that come from the Zoom API as well that can help analytically. Okay, and then there's some documentation that we're putting together as we build all this stuff. I'm not going to go a whole lot into this, one, because it's still work in progress, especially things like the definitions in the ERD. The Zoom API, that's provided by Zoom if you ever want to know what we're hitting and what else is out there. If you feel like there might be some information that would be valuable, we could potentially add that to the job. Anything that's available is documented within their API. The one I am going to pull up is our internal process documentation. And this is just kind of a brief overview of what we're doing, how we're doing it, what the status is, things like that. So there's a lot of information in here if you're really curious. All right, right on time. Any quick questions on Zoom data?
I have one really quick one. Being a PhD student, I have one class that runs through the link of ASU Sync, but another one that the faculty person set it up outside of ASU sync and is still using that one. So the ASU sync doesn't actually go to the class. So this would, the foundational assumption is that the faculty would be using their ASU sync correctly, correct?
Yeah, there's a lot of challenges we've encountered with trying to match up the Zoom and PeopleSoft data. And there are a lot of intricacies that can throw things out of whack. We do not have a perfect match rate. For instance, if we look at sync-only classes, so classes that must have a sync session, we only get, I want to say like an 80 to 90% match. So that means 10 to 20% of the classes we've been unable to match so far. So we're constantly looking at ways to improve that. That's where those additional data tables will come into play. I took a class where we actually used an NAU Zoom link at one point. So absolutely that's not going to be captured, right? Because we don't have access to NAU data. So yeah, it's really nice when people do things by the book. And if they don't, it's out of luck.
Thank you.
Okay, so the next topic is Alteryx Macros. So I did an advanced Alteryx presentation at the conference last year, and there's a little bit more discussion in this area. If you want to go check that out, if you're really interested, there's some examples. I'm not going to go into that much detail here today. So what are macros? If you've used tools like Excel, you know what an Excel macro is, or Google Sheets has macros. Lots of tools have something they call macros, and ultimately all they are is a repetitive process that gets bundled into a code block that you can then implement over and over and over. And that's no different from Alteryx. So here, this is the pivot binding macro that we'll be discussing next. In the workflow, where it's implemented, it's just a single tool. But on the back end, behind the scenes, within that single tool, is a bunch of other tools. And what this does is allows us to take all this code and use it over and over and over without having to copy it over and over and over into every workflow. Because there are some tools, like the data cleansing, which I might use 20 times in a single workflow. You don't want to copy the behind the scenes stuff 20 different times, especially if you need to make a change to it. So that's one of the important things is I can go in and change something in this macro, and all the workflows that use it now get the update. Where can you get macros? So lots of macros are built in. For instance, I mentioned the data cleansing. So Alteryx comes with a lot of tools. Some of those tools are macros, some aren't. I honestly don't know what the difference is, but I'll show you in a minute how you can look behind the scenes of the ones that are. You can download macros from various community outlets. So the Alteryx community space, gallery.alteryx.com. You can download macros that other people around the world have created. There's a lot out there. It can actually be quite challenging to find what you're looking for. The website's not great either, but it's worth it. I found some really good stuff out there that I've used quite a bit. If you do use something provided by the community and you want to schedule it on our ASU Alteryx server, you have to then have that macro added to the ASU repository, otherwise it won't run. So if that happens, put a note in the Alteryx Slack channel, let them know, we'll take care of it. Then ASU's UTO department also provides some Alteryx macros within the WorkDocs directory. So within WorkDocs, in your shared with me, there should be a folder called Alteryx Macros. And those are the ones that are already available on the gallery as well. So anything you find in there can be scheduled, no problem. And you can always build your own. So we'll get into that a little bit. So as I mentioned, some things are included. This is the data cleansing tool I was talking about. If you have that tool out on your workspace, if you right click on it, you can just click on Open Macro, and it'll bring up a new tab with the actual workflow that is being run. I've had to do this, for instance, for some of the Alteryx predictive tools that are based in R. they're kind of limited as far as the user interface of the macro itself and what it allows you to do, but you can go behind the scenes and you can tweak that R to do what you want it to do. So just because Alteryx doesn't do something natively doesn't mean you can't make it happen. Okay, so the components of a macro, and we're going to talk about the different types of macros in a minute. Ultimately, what it boils down to is you can send data into the macro. The macro can send data back out into the parent workflow. And there are inputs that the user can interact with to control the macro. And all of these functions are found within the interface tab of your toolbar. So you've got macro input, this is your data input, macro output, that's your data output. Things like numeric up, down, radio button, text box, tree. Those are all your user controls that go into your interface. I haven't used a lot of these. When you connect the tools, you'll automatically get some actions that pop up. I'm not going to go into details about how all that happens, but there's lots of good materials on the analytics community as far as videos go on how do you create macros, things like that. Control parameter, I think, is just used for batch macros. It's kind of a weird one, but it does come in very handy sometimes, even when you're using it for something it's not meant to do. So let's say you've got a macro out there and you want to add it to your workflow. You can just right click in any of the white space, and at the very bottom of your tool options will be a little macro thing, and you can just browse your computer, locate your macro, select it, it'll insert it into your workflow. Now, if you find that tedious to do over and over, you can actually go into your user settings, and there's a little macros tab in here, and you can map the folders on your computer or network drives to actually populate within Alteryx. And that'll create new tabs within your general toolbar for those different folders. So right here, I'll have two new tabs, one labeled macros, one labeled advanced join, pointing to two different directories from my Dropbox folder. And that's nice. Okay, so I mentioned different types. There are standard macros. There are location optimizer macros. There are iterative macros, and there are batch macros. Talk briefly about them. So standard is what I've shown you so far. It's just a block of code that gets run in line with a query. Pass data in, data comes out, macros done. Okay. Batch macros, you pass data in, it can pass data out, but there's also that control parameter. And what that does is feeds in another set of data, which is the control parameter. And you can use that control parameter to, I don't want to use the word iterate because there's an iterative macro, which is different. But it goes through that list and runs that macro once for everything in the list. Okay, this has been very valuable for lots of very strange scenarios as well as common ones. Iter macros, I haven't actually built one of these. I do have a couple of use cases in mind, but it's similar to a looping function you'd find within any traditional programming language. It's going to continue doing something until you hit that stop criteria. One of the things I wanted to do was look at the HR data. If you're not familiar with the HR data, it's kind of ugly, but it's hierarchical. And so if you want to navigate that hierarchy with an unknown potential number of levels, you have to have a looping function. And this, as far as I can tell, other than doing something really wonky with the batch macro, is the only way to actually loop in Alteryx. And then finally, location optimizer. I copied this from the website. I've never used this. I have no idea what I'd use this for. But if you do a lot of geospatial analysis, chances are you're going to want to use this at some point. We just haven't done it so far. All right, right on time again. Any quick questions on Alteryx macros?
Yeah, I got a quick one, Josh. I'm pretty comfortable with the standard macros. I would like to have something where I can iterate through like several sessions or several weeks, something like that. Is that best done in a batch macro or an iterative macro?
Definitely go with the batch macro.
Okay, and just give it a list of the session numbers or something like that.
Yep.
Yeah. Okay.
That's
what I thought.
Something I should mention: if you're doing something like that, you don't have to have data inputs. You don't have to have data outputs. You probably want to have at least one of those, but it could be you feed in a list of sessions, and that macro includes a query tool as your data input, and then you just output it to your workflow. So you might run a query over and over and over, output, output, output. And also what it's going to do is just union all those outputs from the query. So it's it would be a weird way to do that, but you could do that. All right, pivot mining. So this has been a pet project of mine for the last few years. It's not polished, but I am definitely looking for use cases. So if you think this might be something that would be valuable to you, please reach out and I can go into it in more detail. We can actually run it through a test case and see how it does. Ultimately, what kind of generated this idea in my mind was sitting through meetings with executives and having a dashboard open and just going through and constantly changing filters and changing what's on rows, what's on columns, just pivoting over and over and over on different variables that they think might be important. Try to identify some sort of a visual pattern within that table, within that chart, within that graph. And it wasn't always successful. It was always tedious. And so I thought, there's logic behind this. There's something we're doing. There's something we're looking for. We should be able to automate this. And so that's what the pivot mining macros do. So it's going to take an input of data that you might use for the input to a dashboard, the input to a predictive model, just very traditional data set. There are some limitations that I'll talk about. And it's going to go through and just say, I'm going to try everything to a limit and show you what might be the most interesting features for further exploration. So instead of trying everything yourself, it allows you to focus. So it's just doing some of that grunt work up front. So I mentioned limitations. You have to have a binary outcome, a yes or a no. That's it. If you're trying to evaluate impact on GPA, for instance, GPA is a continuous variable, it's not going to work. Now you could turn it into something that's, did they have a GPA above 3.0, yes or no? Now it's a binary that can actually be utilized. And then the covariates that you're looking at, things like academic plan, college, academic level, GPA, all of those have to be categorical, at least in the current versions. So GPA, again, itself, continuous variable, can't be used as one of the covariates. But you could bucket GPA between 0 and 1, between 1 and 2, between 2 and 3, 3 and 4, and turn it into a categorical variable. But right now, there's nothing to do the categorical conversion for you, although working on it. Okay, so it's going to calculate an outcome rate based on that binary variable. So if your binary is, did they retain, yes or no, it's going to essentially calculate your retention rate. And it's going to do that for tons of different combinations of the covariates. So what's the retention rate for academic level equals freshman, gender equals female, college equals engineering. And it's just going to go through all these variables, put them into combinations, look at the values within the variables, combine those, and calculate these rates. And then it's going to compare all those rates to try to find something interesting. Okay, so from the user side, it's a macro. So you just stick it in your Alteryx workflow. There is a parameter you can use to indicate the minimum segment size. So what is the smallest number of students that I want to kind of filter this down to? So if you have female students in engineering under the age of 18, and there's 10 of those, and your minimum is 30, which is the default, we're just going to kick that population out and say, you know what, that's just noise. We don't really care about it. Toss it out. There's two different kind of versions of the macros in general. One that just looks at a single point in time, cross-sectional perspective. And there's one that looks at 2 points in time, and it actually calculates lots of metrics relative to the change over time. Working on trying to figure out a way to do more than 2 time periods. No great ideas yet. And there's different macros for if you just want to do 1 variable at a time, if you want to do 1 or 2 variables at a time. And then there's one for 1, 2, or 3 variables at a time. So you can look at gender, college, GPA category all at once, or any other variable up to 3, or up to 2, or up to 1. Those are just different macros. Working on a way to just turn that into an input. But I think it's going to involve an iterative macro inside of this macro. Let's see. And I kind of explained what it's doing on the back side. It's, again, just combining all these variables, combining all these values, calculating rates, comparing rates. It's also going to calculate measures of statistical significance. So given the rate, given the population size, all this stuff, it goes through some crazy binomial something or other. I had help with that. Not my area of expertise for sure. And it's going to kind of tell you the significance levels of these different patterns that are coming out. It's also going to go in and try to identify combinations which are actually misleading. So if you're familiar with Simpson's paradox, we're working on implementing code to identify Simpson's paradox within the data. And that says, you can look at the variable combination of college, career, and ethnicity, but there's more to that story if you add in something else, because the pattern you get with that combination is not the same as the pattern you get when you add in another variable, and it's all in a different direction. Kind of hard to explain, but if you go to Wikipedia and you look up Simpson's paradox, there's an example for Berkeley admissions, which is fantastic. All right, so again, documentation. Got a Google Doc with the overview, a process diagram that kind of shows you how the logic works inside the macro, and a data dictionary for the output variables, definitions for those. Still in progress, very much. The overview is pretty complete. And so if you go in here, again, it's going to go through if you're interested in any of the math that happens, calculating any of the measures, the statistical stuff, how the Simpsons paradox works, all these things. We're also trying to do something with a measure of variance, kind of similar to an ANOVA analysis, and implementing that as well. Really quick example. So taking a basic query that you might find with a dashboard, predictive model, it's just measuring retention year over year as of some point in time. All we're doing is taking that input, putting it into the macro, and I have 2 different variations of the macro here. and then data comes out. That's simple. Lots of stuff comes out. This is where the data dictionary comes in useful. It's meant to be broad enough to help out with a number of different types of use cases. But generally it's broken down into 3 different portions. One is the overall. This is just for all the students in your population. This is how many there were. This is how many there were the next year, if you're doing the time-to-time comparison. This is your growth rate. This is your retention rate, or whatever your outcome is, GPA above 3.0 rate. And the variable names where you see retained all in caps here, that's automatically populated with whatever the header was for your outcome column. So be cognizant that if you want that to be understandable, you want your input data to also be understandable. And it's going to go through and look at all these variable combinations. It's going to calculate how many segments are there within these combinations, what's the average number of students per segment. Some things that you probably won't use most of the time, but can be helpful to create context around some analysis. But this is also where you'd find instances of Simpson's paradox, for instance. And then you have the segments. So this is specifics, right? So it might be simply nursing plan, or it might be nursing plan within the nursing college. Well, those are the exact same thing, because that plan can't exist in any other colleges. So you're going to find a lot of variable combinations that might not be useful. But again, it's just looking at all combinations. So it's up to you to figure out which combinations are functionally meaningful. It's going to tell you which ones are numerically meaningful, but it's up to you to figure out the functions. But we're looking at all these different combinations, again, counts, comparing to the overall. That's a big one. So what's the growth rate for this segment compared to the overall population? Or what's the retention rate of this segment compared to the overall population? And we have some of that stuff. It ranks everything. So this is the highest segment when it comes to retention rate being better than overall. And again, statistics. So you get Z-scores. We bucket those by 1, 2, and 3 standard deviations. And then we have significance levels based on the p-values, 80%, 90%, 95%, 99%. So there's different options there as far as significance goes. And that is pivot mining. That one went a little bit longer, and I think the next one's really long. So if anyone has any really quick questions on pivot mining, we can do that. Okay. So SQL development, best practices and considerations. And I am acknowledging fully upfront that while I'm considering these to be general best practices and considerations, absolutely doesn't mean everyone should do this all the time, okay? This is guidelines, not law. So you might check the calendar out on Friday from 9:30 to 10:20. There's actually 2 presentations on SQL. David's, I believe, is going to be more entry level. So if you're just getting started with SQL, this is a good place to go to understand the constructs, the terminology, things like that. Laura and Ezzy are going to be doing one that's more advanced. And a lot of what I'm about to show you came from Laura. So if you want more details about any of the stuff that I'm about to go through, absolutely check out their presentation. Okay, so just because your SQL runs and gives you accurate results doesn't mean it's good. Okay, you got to accept that up front. This is kind of the direction that I think SQL should go. So primary consideration, it needs to run. Obviously, if it doesn't run, it's completely useless. It needs to produce consistent results. Data changes in ways that might affect the logic. You might not fully understand the data. Consistency is key to ensuring longevity of the SQL that's been developed. Faster is better. So I started to talk about performance, right? The faster you can get that to run, the fewer server resources that are being tied up in order to do it, the lower the impact on everyone else. And the faster you're going to get your results. So that's good too. So you've got everything running pretty quickly, consistently. You can still make it better by doing some pre-processing. So you can break that SQL into separate statements and then store the results from the early segments. So if you've got something that you think, oh, hey, this code block right here would be useful elsewhere, you can process that separately and then take that table that's created from the initial code block and create and use that as an input to the second. And that can actually improve your performance as well. And consider long-term maintenance. I probably don't do this often enough, but the more I work in UTO, the more I hear about this. So making sure that what you've developed is not just stuck in your head. Okay. So your SQL run, I have some examples here of tools that just have these weird quirks. And so running those statements in multiple tools can help make your code more sustainable, more flexible, more extensible, ensuring that someone else who you might give that code to can also use it. Yesterday, I got to hear about from Shelly about how the code I wrote in Toad doesn't run in dbeaver. Not sure what to do about that now, but example of how problems can happen through no fault of your own, but there's ways to prevent it. When you're doing your development, throw a limit function there. If you're doing Oracle, row num less than 100, whatever. A lot of IDEs will do this automatically, but there's no point in running a 30-minute long query if all you're looking to do is see if the logic you used to, or case statement logic for a single column was working as intended, right? And obviously test if you are trying to match something, test it to match. Okay, consistent results. So specificity and granularity. I really want to talk a lot about this. We don't have time for it. There are things that happen within the data that you can account for in different ways to get different results. For instance, doing a select star, you're going to get all the columns, no matter what those columns are called, right? But if that SQL is then being thrown into Tableau, your dashboard can break because you are referencing a column which is no longer returned. If you'd like to have the problem occur within Tableau, that's the way you want to do it. If you'd like to fix that problem in the data side, in the query side, then you might want to do select specific columns, right? So there's little tweaks you can make to enforce a specific output or to make a specific output flexible. Like if I know I want one record per student, I can throw a row number function in there, partition on students, and select row number equals 1. No matter what happens, I'm only going to get one record per student. But there's no guarantee it's going to be the record I want. And if you misunderstood the data that's being generated, or the logic isn't quite there, or the data changes, you might end up missing records that you actually would have cared about. So there's different approaches to produce different types of outcomes. Faster is better. Got some tips here. Go to Laura's presentation. She's going to go through all this plus much more. Almost guaranteed. I haven't verified that, but strong suspicion for sure. There are different things you can do that will make your code run faster that might not be trivial or intuitive. I talked about pre-processing. So, building those tables will simplify your SQL long-term, makes it more understandable for people, makes it more manageable, makes it more extensible. And long-term maintenance. This is really just Document within your code, document outside your code, document your code in general. And there are certain ways that you can write that code to make it easier to maintain as well, right? So if you're doing something crazy, definitely document it. If you're doing something incredibly trivial, not so necessary. The more that trivial stuff you do, the shorter your code is, the easier it is to understand, the easier it is to maintain. The less likely you are to open that code 3 years from now and not have a clue what's going on. Okay, and alias your code, meaningful aliases, please. I've had some fun recently just going into things like Reddit and looking up tab versus space debates. So do you use tabs to indent your code or do you use spaces to indent your code? Ultimately, what it comes down to is it doesn't matter. Just try to be consistent. Lots of people have done all kinds of performance comparisons with the two. Spaces make your code bigger because typically, assuming your space is more than one, it makes your code bigger. Unless you're running absolute bonkers amounts of it, it's not going to affect performance at all. Personally, I use spaces now because I've noticed that no matter what tool I open it up in, it'll look the same. If you use a tab, tabs don't always have the same number of characters, so indentations sometimes look goofy with tabs. All right, closer to being on time. Any quick questions about that one? Cool. All right, data architecture. So I'm going to talk about operations versus analytics. And I definitely wasn't doing this during the opening session today. This is probably my favorite topic. I'm hoping this one will have at least a few minutes to have a discussion, because I think this is ripe for debate, especially within educational environments. So operational data. This is what you see in things like PeopleSoft or some parts of Canvas. This is specifically what we need to have in order to keep things moving along. It's hopefully current as of right now, right? We don't necessarily care what happened yesterday in many circumstances, because it might not actually affect what happens today. Now, there are some places within operational data, things like PeopleSoft audit tables, which go a step further and try to provide some sort of very accurate history, but even those are typically quite lacking when it comes to analytical requirements. The other thing is it's only as accurate as it needs to be. They're not going to typically fix data that isn't impacting something. So if you look at the admissions process for undergrads, you can be admitted with a GPA above 3.0 or high school rank in your top 10% or SAT score above 1100 or ACT score above 28. And that means if you get admitted on one of those and the other one's not accurate, they really don't care. You only need one of those to be accurate in order to admit a student. And that data might not ever be used again. So it's not going to get fixed. If you look at the data, you'll see ACT score of 1200, but that's obviously not right. It's impossible. But operations isn't going to try to fix those. However, it can be really useful for analytics. So analytics evaluates these operational processes, right? We're trying to improve upon them when possible. And what this means is you often require that point in time data. You need to know, as of today, I'm going to guess 40th day of fall. How does our situation right now compare to the 40th day of fall the last 4 years, right? And if you have that information, you can say, okay, well, maybe we can get in the direction of how COVID has impacted our operations, right? But the data required to do that isn't generally captured. And then there's an additional complexity where if they do fix bad data and you have point in time records, do you want the point in time bad data or the good data? And different use cases might answer that question differently. So there's a challenge there as well. So the Actionable Analytics Data Mart, which again, I have a presentation on tomorrow, if you're interested, has been our approach to creating truly analytic data at ASU, specifically intended to support student success. Okay. So the Actionable Analytics project, if you're not familiar with it, has a few different components, building predictive models, similar to what you'd find with the Civitas platform. They are building some dashboards, and they're building something called Campaign Builder, which allows people to generate lists of students for outreach purposes. And at the center of all this is the data mart that's creating the data that feeds these different applications. And so the structure that we've generated is what we're calling slowly changing things. It was originally slowly changing tables, SCT, and then we created a view, and we're like, well, it's not really a table, so SCT doesn't make sense. But if we call them slowly changing things, SCT still makes sense. And so what that does is it captures all changes to the source data, and I'm going to specify are as cleaned up as possible source data. So we implement logic before we store anything to try to fix what problems we can find. And we don't lose any history. So, you know, as of any date, what action was taken or what this attribute value was. And that record, like you'd find within a snapshot, is dated. But instead of repeating that exact same data for 100 different days, if it never changes, we capture it with a start date and an end date. So this data was valid from date A to date B. And what we can do with that structure, which is an efficient way to capture changes, unlike a snapshot, which uses a lot more space, is you can identify what's the current value, right? Similar to what you'd get from operations, but all that cleaning logic is then persisted. And we also create what we're calling simulated snapshots. So they're not actually snapshots, we're simulating them. And that has what's ultimately a snapshot date. So you can see what was the data as of this specific date. Okay, and so in the grand scheme of things, we've got our source data for HT using those 3 different constructs. We're creating what we're calling these core tables. This is really just truly enriched data where we've done some level of aggregation, typically, something like you'd find within the student profile tables. Again, using those 3 different constructs. And then we're feeding them into these different applications, but we're also going to be making this available to other people within the university for their applications. I keep saying applications. Delaney's probably going nuts right now for their different uses. Hopefully dashboards and things like that, which are meant to hit Redshift. And then very briefly, initial areas of focus. So we started with service indicator data, especially the service indicator impact, which we know we lose history in PeopleSoft. So that was an important one. We're looking at enrollment because we know enrollment records get deleted. So we want to make sure we capture that history accurately. And we're going to be doing the prog and plan stats because we know we lose data there. So we're really right now focused on not losing information as much as possible. And then simultaneously, we're going to be kind of building out some of these more enriched areas. And we're starting with some financial aid, student aid year level tables for that. So I'm very curious, as far as priority goes, if anyone else has noticed areas where history is being lost that is potentially valuable to analytics. Other than that, on time. So they don't have anything for operational versus analytical data, any data sources they're aware of that we should be capturing. Y'all are a very quiet bunch.
So again, what you were saying, this is typically for reports and dashboards and really digging into the data to figure out. Only I'm saying this because you used the word application. I know you know.
As soon as I said it,
what does that mean for you? Like, when you say that, what does that mean? What is the downstream for folks when they're looking at that?
So when I say application, I mean how something's being applied, right? The application of super glue, right? It's not a technical application that's being developed. It's how something's being applied. And so, yeah, we're really looking at analytic focused reports and dashboards for additional downstream uses. And that's a lot of what the BI community is building. We have application development.
It's robust. These are great tools.
Yeah, lots of tools out there, lots of people. It's a growing area. But what we're hoping to do is really kind of fill some gaps that exist within the data to support all those users and all those different uses.
So if folks find gaps or they come up after this, session with, here's some history we need, here's some things that we don't see, where would they go?
So I'd probably just Slack me if you think there might be something that needs to be added. If you want to know what we're developing, we're going to be starting with a Google Sheet to kind of document everything that's been developed. And then hopefully we'll also be adding that information into Collibra as that platform matures. So you'll be able to find.
Is there an additional Slack channel that they can go to, maybe not directly to you, or is there, I mean, you may answer, but.
I'd love to have like an actionable analytics data Mart channel. I don't know if that's going to happen. I think Jennifer's has joined us. Maybe she could weigh in. But
I've been here the whole time, Josh. I think Delaney, we're working on roadmap with some key stakeholders, and as soon as that is sort of outlined, we will open up to more public comment.
Great. Great presentation. Thanks.
All right. Anything else? Can't believe we made it on time. Although if anyone has ever seen me present before, to be expected, there was going to be more content than we had time for, and I was going to talk really fast. All right. Well, thanks everyone.
Thanks, Josh.
Hopefully you all learned at least something, and I'd really like to keep these conversations going. So hit me up.
Hey, Josh. I know there was some comments about the recordings are going to be kind of curated. Do you think that it'd be reasonable to ask them to break this up into your various into your segments? Because I think people may want to just watch Pivot Miner, for instance. So you might suggest that.
Delaney and I had that conversation yesterday.
Yeah.
Okay. You guys are way ahead of me, of course.
Now that I know they're doing like YouTube stuff and they're actually doing some processing, I suspect
they're going to break it out. I have a feeling they'll either break it out or they're going to say at this time mark are these different starts of the subject.
Yeah.
Something like that. It's either going to be one or the other, I would imagine, since it's going to be posted that way. So.
Super. Okay.
But yeah, that's something, we totally had that conversation about how do we want to break this out, and for less disruption, it was easier to keep recording. So awesome.
Right. Cool. Thanks everyone.
Have a great one.
Enjoy the rest of the conference.